Okay, so last time we talked about evaluating composite functions, but doing so with a specific value in mind, a particular number. So instead of just g of 3, we found f of g of 3. And I want to start today with a couple of example problems that have that same format as what we looked at last time. Okay, so we've got a table here, we've got some functions, we've got some graphs at the bottom of the page. We're going to do a really quick review for everything that we have looked at so far with our composition of functions. Okay, so for f of g of 3, remember when we're evaluating a composition, we start with the insides. We start with g of 3. So g of 3, if I look at my table here are my x values, and then f of x, so my outputs for f, and my outputs for g of x over here. So g of 3, when my input is 3, for g of x, our output is 2. And that's the inside piece. And now I take f of 2. Remember, for a composition, the output of one function becomes the input for another. Now we take f of 2. So when my input is 2, my output for f of x is 8. So f of g of 3 is 8. So we did this with a table, with functions, and with graphs last week. So we're going to review all 3 of those today as well. When I've got a function here, like our next example, we're going to find f of h of 1. We, again, work from the inside out. So we're going to start by finding h of 1. So we're going to plug 1 in anywhere I see an x in my function h of x. This would be 3 times 1 plus 2. So that's 3 plus 2, which is 5. Now we do the outer function, f of 5, f of 5. The output for my first function becomes the input for my next. So f of 5. So in f of x now, anywhere I see a variable, I'm going to plug in 5. So this would be 5 squared minus 5. So 25 minus 5 gives us 20. So f of h of 1 is 20. Look familiar? Okay, this is what we did last week. And now we can do this with a graph as well. So we focused on 3 major representations for functions: a table, a function, and a graph. So we're looking at our third representation here. And it works the same way. Here's my graph for g of x. Here's my graph for f of x. We start from the inside and work our way out. So g of 1 means we're looking at the g of x graph, and we've got an input or an x value of 1. That means our output, our y value, would be 3. And now I use this as my input for f. So we'll find f of 3. We have to go over to our f of x graph now. Our input is 3. Follow that to the graph. And our output, our y value, is 6. So f of g of 1 is 6. That is a very quick summary overview recap of what we looked at last time with compositions of functions. Okay. On the next page, I want you to start with a few more problems similar to what we looked at last time. So I want you to look at, we're on page 31 for our packet this time. I want you to look at these first 3 problems, 1, 2, and 3. You have 2 new functions defined up at the top, f of x and g of x. I would like you to find f of g of -5, g of f of 3, and g of 0. So I want you to find these first 3. That's just like what we did last time. You try those. Again, using those 2 new functions, f of x and g of x, up at the top. check your answers here, and if we want to go through the work, we can. F of g of -5, you should have gotten 20. Would anybody like me to work that first one out? Go through the steps on that one? Okay. The second one, g of f of 3, should have gotten 18. Anybody like me to work through the second problem? And then the last one I asked you to try, g of 0, you should have gotten 42. Anybody like me to work through this one? Okay, so we start with g of 0. So g of x, I'm plugging in 0 for x. This would be 0 squared minus 7, which would give me -7, right? 0 squared is 0. 0 minus 7 is -7. Now I do g of this guy. So g of -7. That would be -7 squared minus 7. -7 squared would be 49. 49 minus 7 would be 42. Does that make sense? Okay. So these, again, are like what we did last time. Here's the change that we're going to make for today. Instead of always evaluating at a specific number, we can evaluate at just x, or we can evaluate at an expression. So that's what we're going to see for today. So if we take a look at our next guy, this is not a composition, okay? But I want to kind of ease our toe in the water for when we get to those composition problems. We want to find f of x plus 4, not f of 4, not f of 2, not f of -1, not f of x, right? F of x would just be the function we had originally up at the top, but f of x plus 4. That means anywhere we see an x in our function, we are going to put in x plus 4. Same idea as evaluating at a number, but this time it's an expression. Okay, so this will look like, and so here's where our x was, it's x plus 2, but instead of x, we are putting in x plus 4. Okay, you guys with me so far? That's weird, I know. And then we're going to combine like terms. So we've got 4 and 2 that we can combine, and that gives us x plus 6. And then that's it. We don't have a value that we're plugging in for x. We've already combined our like terms. So f of x plus 4 will give us x plus 6. And that's it. Okay. So that's our new idea for today. And again, we're doing a couple where we're just evaluating a function, not a composition. So let's look at our next one, g of 2x. So that means we're going to take g of x, and anywhere I see an x, I'm going to plug in 2x. So this would be, we've got x squared. We're going to plug in 2x there, minus 7. Now be careful with your exponents. Remember, this means 2x times 2x. When we square, that means that thing times itself. So this would give us 4x squared minus 7. And that's it. That's all I can do there. I have no more like terms to combine. There's no more operations that I can do. So g of 2x would be 4x squared minus 7. Our next problem, f of x squared minus 10, means we're going to take our f of x, which was x plus 2, right? X plus 2. And we're going to fill this x squared minus 10 in that spot that x was. And now we combine any like terms. So I've got minus 10 plus 2. We can combine those, and we get x squared minus 8. So f of x squared minus 10 gives me x squared minus 8. Now we're going to do that same idea, but with compositions. Okay. And I want you to notice for our compositions down at the bottom here, it's not x squared or x plus 2 or x squared minus 10. It's not anything super funky. It's just f of x for these first couple. So we'll start from the inside out. G of x. Well, since it's g of x, that's just the same thing that we already have printed at the top of our paper, x squared minus 7. And now, just like our composition problems from last time and from the start of today, we're going to plug this in for x. So our f of x function is x plus 2. So this would be x squared minus 7 plus 2. Right? Here's where x went, so we plug that stuff in for x. And now we'll combine like terms. Negative 7 plus 2 gives me x squared minus 5. So f of g of x is x squared minus 5. So now I've done this with a composition. We're going to do one more with these same functions, a composition. This time I'm switching the order. This time g of f of x. So we'll start with f of x. F of x is x plus 2. And then I'm going to use this output as my input for g. So this would be x plus 2 squared minus 7. Remember, our original g of x was x squared minus 7. So we plug x plus 2 in for x. Be careful when you've got exponents and you're going to like distribute or multiply. Okay. Remember, this is x plus 2 times x plus 2. So we need to distribute here. So this is x squared plus 2x plus 2x plus 4 minus 7. Don't forget that minus 7 at the bottom, or at the end, I should say. And then we combine our like terms just like we did above. So a little bit more work to do on this particular problem, but it's exactly the same idea as what we've done for all of our composition problems. So this would give me x squared plus 4x, and then 4, and negative 7 would be minus 3. So g of the f of x is x squared plus 4x minus 3. Questions for me so far? On the next page, we're going to see some new functions, but we're going to work through some more together before I turn you loose. Okay. So on the next page, we've got a new f of x and a new g of x. New f of x and new g of x. We're going to start with some values. Okay, just like we did before, we're starting with some values. So f of 2. So we're going to work from the inside out, just like before, f of 2. We're going to start by finding f of 2. So we're going to plug 2 in for x in f of x. So this would be 2 squared plus 1. 2 squared is 4, plus 1 is 5. And now we're using f again. So I'm going to find f of 5. Right? The output for my first function becomes the input for my second. And this would be 5 squared plus 1. 5 squared is 25, plus 1 is 26. So f of 2 is 26. And then together, we're going to work down the column this time. Instead of going back and forth across, we're just going to go down this first column. For our second problem here, f of g of negative 4, we're going to start with g of negative 4. So g of negative 4 means we are plugging negative 4 in for x in our function g of x. That'd be the square root of negative 4 plus 2. which would be the square root of -2. Now, what do you want to tell me at this point? There should be something you want to tell me about this. It's not real, right? Not real or maybe undefined, okay? There's a reason that we're doing this one together, so stick with me for just a minute. We're gonna take this square root of -2, which is not real, right? Still not real. We're gonna take it and go ahead and do that next step. So we're gonna do f of the square root of -2. When I put this into f, I would have the square root of -2 squared plus 1. What happens here when I square the square root? It goes back to whatever was inside that root, right? So the square and the square root sort of undo each other. And I get just -2 out of this, plus 1. Now we're back to something that's real. So this one was a little funky. There's a reason we did it together. And we get -1. So f of g of -4 is -1. Now let's try it with something that is not a value. Okay, we've got a variable in here, f of 4x cubed. Again, this one, not a composition, just evaluating f, okay, not a composition. We're gonna plug this in for x in our function f. So remember, f of x was x squared plus 1. So this would be 4x cubed squared plus 1. Remember, when I square, that means 4x cubed times itself, times 4x cubed. So when I'm multiplying these, 4 times 4 is 16. And then x cubed times x cubed, that would be x to the 6th plus 1. If you feel a little shaky on those exponent rules, that will be the first thing that we cover in our next unit. We're coming up soon. A little refresher on those. At this point, I have no more like terms I can combine. There are no more operations to do. So f of 4x cubed is 16x to the 6th plus 1. And now let's look at a composition. G of f of x. So we start with the inside, f of x is x squared plus 1. And now that becomes my input for g of x. So for g of x, we have the square root of x, which we are replacing with x squared plus 1, and then plus 2, right? This was our x part, plus 2. Combine our like terms under the root here. We would get the square root of x squared plus 3. And then that's all I can do. Since we're not plugging in a value for x squared, I don't know if this simplifies to a nice number or not, based on the way that it's written. Since it's addition, I cannot break up my root here. We will just leave this as the square root of x squared plus 3. I would like you now to try the other column on this page. So we did the left-hand side. I would like you now to try the right-hand side. time on these. You don't need to speed through them. Okay, let's work through these. F of g of 3. Okay, these are the old problems. So work from the inside out, start with g of 3. That means I am plugging 3 into my function here. This would be the square root of 3 plus 2, which gives me the square root of 5. Do we know the square root of 5? It's not a nice number, right? 5 is not a perfect square, so this isn't going to come out to be a whole number. I do not need you to type it in your calculator. Don't give me a decimal here. Let's now use this as our input for f. So f of the square root of 5. So that would be, for our function f of x, the square root of 5 squared plus 1. And then what happens when I square this square root of 5? The square and the square root sort of undo each other. And we get 5 out of there plus 1, which is 6. So f of g of 3 is 6. A little tricky there with the square root. Hopefully not too bad. Next is g of x plus 7. So that means we are looking at our function g of x, and we are putting this in anywhere that we see an x in that function. So for g of x, that's our square root. It's the square root of x plus 2. So we are putting in x plus 7 plus 2. Now we've got some like terms we can combine under the root here. So this would be the square root of x plus 9. And then there's nothing else for me to do here. 9 does have a square root, but it's not just the square root of 9, right? It's the square root of x plus 9. I can't break up that addition, so we will just have the square root of x plus 9. And now we've got some composition, f of g of x. So we start with g of x. And this is at the top, but I'm going to write it down here. So g of x is the square root of x plus 2. Now this is what I use for my input for x. Right? The output of the first is the input for the next one. So this would be, for f of x, it is x squared. So the square root of x plus 2 is what I am squaring here. And then plus 1 at the end from my function. I'm squaring another square root. We've already talked about this a couple of times. So when I square that square root, I am left just with what was under the root, which is x plus 2, plus our 1 at the end. Combine like terms, and we get x plus 3. So f of g of x is x plus 3. Questions for me on this one? Okay. Last one on this page, g of x. So g of x was the square root guy, square root of x plus 2. And now I am plugging that into g again. I'm going to use the square root of x plus 2 as my input. So this one's going to look a little funky. That's okay. So this would be, in for x, I put the square root of x plus 2, and then I've got plus 2. So I've got some sort of nested square roots here. This looks weird. That's okay. So what's g of x? It is the square root of the square root of x plus 2 plus 2. The last one was weird. That's okay. Last thing for today. Turn the page for me. We've got a new set of functions. And we're going to do this one more time. I want you to work on, this time, the left-hand column of problems. So we've done this several times together. I've asked you to practice them. We've checked them. Okay. Now this page, I'm going to turn you loose. Okay. This left-hand column, I would like you to try with your two functions up at the top here. I walk around. They're doing really well. Alrighty, our very first problem for this last set of functions is evaluating at a number. So we want to find g of -1, right? We're working inside out. We're plugging in -1 to our function g of x. So this would be 5 times -1 plus 1. That's -5 plus 1, which is -4. And then our outer function is also g, so we'll find g of -4. Okay? Output for the first function is input for the next one. So this would be 5 times -4 plus 1. This is -20 plus 1. We get -19. Any questions on this first one? Okay, let's take a look at the next one down. This time, g of 2x minus 10. So we're using our g of x function again. So this would be 5 times 2x minus 10 plus 1. So I've got some distribution to do here. This would be 10x minus 50 plus 1. Combine your like terms, and we get 10x minus 49. Questions on the second one? F of 4x squared. So f of x is just the absolute value of x. So this would be the absolute value of 4x squared. That's it. I don't need to do anything else on this one. And then our last one, our composition here, g of f of x. So we start with f of x. F of x is the absolute value of x, right? I took that straight from the top of our paper. And now I'm going to put this into g. So g of the absolute value of x. This would be 5 times the absolute value of x plus 1. There are no like terms to combine here. And I can't simplify this anymore. Now we can make an argument for the problem right before that this is actually going to be the same thing as 4x squared. Okay. And for real numbers, it would be. Okay. For real numbers, it would be. But there are cases that we'll see later on where if I dropped the absolute value bars, then we could possibly end up with negative something here at the end. So I don't want to do that. Okay. We'll keep those absolute value bars. Here, for sure, we should be able to see I definitely need to keep those absolute value bars. I cannot say that the absolute value of x is x because when I go to evaluate this at a specific number, this is going to depend whether it's positive or negative on what that value is. If I plug in 2, it's fine, and I don't need the bars there. If I plug in -7, it's not fine. I need those absolute value bars there. So I'm just going to leave this here. Okay. Questions for me for today? All right, we're going to stop there in our notes packet for today. You do have a homework assignment on Delta Math for tonight. And we've got a little bit of time to be able to work on it.